Morning, everyone. Just a friendly reminder right off the bat to make sure that phones are put away, earbuds are taken off, backpacks are on the ground. Don't need Chromebooks out. You're going to want to get your paper notebook with a pen or pencil as we are going to be taking notes today.
More notes?
More notes. Obviously, if you ever have any questions while we're taking notes, feel free to either jot those down if I can't get to them immediately, or raise your hand and you can ask those and we'll discuss them, which is always a positive sign that you are making connections with what we're trying to teach you and what you're trying to learn. Slightly changing up a few things with this kind of iteration of our notes. Nothing too major, but at the end of every class period we're going to be asking you guys to write notes on the opposite side of your notebook. So instead of trying to do that at the end when all the notes are completed, we'll just do that every day now, kind of as our exit ticket, okay? Also at the beginning of class, we'll continue to review, give you time to modify your notes on most days. And then we're going to have our bell ringer question at the beginning. So we're not going to have Plickers cards during the duration of the presentation, but it will happen at the beginning of the class period from now on. Just to kind of, I guess you would say, do a quality of life update, so that way it's a little bit more consistent across school days. And with that being said, as you are continuing to get set up, just a reminder that the reassessment for our previous test that we took on Thursday is going to be due at midnight this Friday. And that's the only quote-unquote homework assignment that you need to be working on this week. And everybody can be doing something on that because there's no A's on that test. So even if you have the highest score in the class, you can still do some type of reassessment to bump that up, okay? All right, with that being said, the next couple days we are going to be running information by you about suspension systems. There's a lot to this, okay? I'm just giving you a forewarning. There is a lot to suspension systems. The caveat here is that I'm only going to try to give you everything that is necessary for you to understand basic fundamental principles about suspension systems on most vehicles. I'm not going to give you the nitty and gritty on a lot of stuff. You might have questions about certain things. I'm going to try to withhold that from you, not because I don't think it's important to learn. It's just might be overwhelming or confusing in regards to the basics, quote unquote. Yes.
So do we get more into this in Auto 2, or do we just leave it as
we do get into more of it. More diagnostics and maybe potentially what can go wrong on this sort of stuff. But I need you to have this foundation first to be able to understand what we kind of get into later on. So we do review some of this information on Auto 2 as well, just because this is so critical to everything else. But by the time we're done with the suspension system, the goal is you not only can identify the type of suspension that's being used on a vehicle, okay, but you're going to also be able to know the names of all the components and parts to that suspension system and how it basically operates on the vehicle and its purpose, right, and all that sort of stuff. So, ASE standards, again, these are not something that you necessarily need to write down, but the expectation is now I'm going to give you guys a couple minutes to write down an essential question that contains, right, your question contains some information that's going to be kind of highlighted up here on the screen. Okay, so let's just highlight these real quick. Students, you will be able to identify suspension and steering system components and configurations. You'll be able to inspect upper and or lower control arms, bushings, and shafts. You'll be able to inspect upper and or lower ball joints that have or do not have wear indicators. And you'll be able to inspect components of suspension systems, coil, leaf, and torsion springs specifically, which makes up the different types of suspension systems we're going to get into. Okay, so you can already see here that These three specifically, A4, C1, C4, and C9, are going to deal with our lab mostly. So you're going to get hands-on experience because inspecting is a verb, right? You have to do it. In order to inspect a suspension system, you also have to be able to identify the components, what their names are, what they do, right? So then that way when you're looking at that or making measurements on it, if it's not doing what it's supposed to be doing, we can denote that, okay? So again, create a question up at the top of your notebook. Who, what, why, when, where, how, incorporating something along the lines that's on the screen, right? So some, again, low-hanging fruit, some very easy questions, right? How many different components are on a suspension system? What is a lower control arm? How often do I need to inspect a bushing? Right? What's the difference between an upper and a lower control or a lower ball joint? What is a wear indicator? Where are the wear indicators? Let's see here. Are there other types of suspension systems other than coil, leaf, and torsion? You know what I mean? This isn't rocket science, and we're not competing over who's got the best question. This is something that you're curious about, maybe you just don't know. Maybe there's everything up here you don't know. So finding a question should be pretty easy. If you write an essential question down that does not deal with what's on the screen right now, it's not going to get answered. Okay? And the reason for that is because this is what we're going to be talking about. This is what I'm going to be answering. Okay? This is what I'm going to be filling in the blanks here for you. So if you're going to go on there going, hey, how do I modify my suspension system so I can drift? That's not an essential question. Okay? That is a question, yes, but it doesn't deal with this stuff. Okay? There's a lot of quote-unquote essential questions when we were going through tires and alignments that did not align or did not meet any of the standards that we had. So students were just writing something down and they didn't have an answer for it because we didn't talk about it. Emerson? No? Okay. Now, if you're curious about that sort of stuff, that's awesome, and I would encourage you to do your own research about that information that we're not going to cover in class. Okay? There's stuff out there where you can learn that. Okay? Typically a Google search away, although granted, I'm not going to endorse that just due to the fact that anybody can post anything online. It doesn't necessarily make it industry standard. Okay? Okay, hopefully that was enough time to do this. And again, I want to highlight and emphasize this. This is information that you can look back on later on to complete your study guides. Okay? You can look back on your notes that you're writing down right now to assist you in preparing and studying for the test ultimately. Because guess what's going to be on the test? Information based off of those 4 standards we just talked about. Okay? Don't feel like you need to write down everything, because if you try to write down everything, you are not going to be able to keep up with me. Also, I want to emphasize this, because apparently it's not crystal clear. There's going to be stuff that I'm going to be discussing with you verbally that's not exclusively written down on the slides, that you're probably also going to want to jot down in your notes. Okay? And mostly the reason why it's not on the slides is because I don't have enough space in here. It would just be all words. Okay? So you got to figure out the best way to summarize the information that's on the screen, listen to what I'm talking about, and kind of get that information on. It's not easy. It's a skill. It takes practice. That's why we do this. All right, suspension systems. What is the purpose of a suspension system on a car? Like literally, if I were just to show you one slide to give you kind of the general overall idea, and especially when we're trying to explain this to maybe like a kindergartner that has no idea about anything, what would we say? Well, okay, it's going to support the chassis. What's a chassis? It's the body of the vehicle. Okay, it is literally the metal of the car, the frame of the vehicle. Okay, that's the chassis. Okay, everything on the vehicle is going to be bolted to or attached to the chassis, including the passengers of the vehicle. Right? You're going to strap yourself into a safety belt. You're putting yourself into the chassis. So the suspension system is going to support the chassis. You're going to keep it off the road as we're driving down. Okay. We're also, equally important, wanting to keep the tires in contact with the road. As crazy as this is, and you already know this, roads are not perfect. They're not smooth, right? They have bumps and potholes and curves and all sorts of things that kind of cover the curvature of the earth. Awesome. We have to design a vehicle or a system on the vehicle that's going to accommodate for all these variations because we don't know where we're driving. Hopefully on a road. But does it have to be a road? No. It could be a gravel road. It could be dirt. It could be a cornfield. It depends on the application of what's going on with the vehicle and where the driver wants to take that. Okay. Now, obviously some vehicles have suspension that's purposefully designed for certain extreme conditions. While most manufacturers are trying to design the vehicle for paved roads. Okay. We also want to control the direction of the vehicle. We want the car or vehicle to go straight when we want to go straight. We want it to turn when we want to turn. Okay? We want the vehicle to be predictable. Okay? The suspension system, because it's keeping the tires in contact with the road, is going to allow us to have control of the direction. We're also going to maintain the correct ride height. Okay? The distance between basically the bottom of the vehicle and the top of the road. Okay, we don't want this thing to constantly botting out and scraping on the ground because that wears out certain parts of the vehicle and our vehicle doesn't run very well. Okay? It also is going to cause the vehicle not to handle great, especially in extreme weather conditions, right? If it's slippery and icy outside, I don't want my suspension system acting up. Again, I want my vehicle to be predictable. We obviously already talked about this previously, but we want to make sure we have proper wheel alignment. As parts age or degrade over whatever things, right? I get in an accident, I hit a curb. Okay, my wheel alignment is going to change over time. Okay, I'm going to have to I'm probably going to have to just replace suspension components and then obviously get that realigned. And then finally, reduce effects of forces as the vehicle travels on the road. Okay. So again, I'm looking at passenger comfort here, right? Hey, I just got a baby. The baby's 9 months old, right? If I'm driving down the road and I'm hitting all these potholes, baby's not going to sleep, baby's not going to be happy, baby's crying. I don't want that, okay? Now you guys will get to that point in your life at some point, right? There's a couple commercials out there too from car companies where they're like, oh, my baby can't sleep. Right? They put it in the car and they start doing laps around the neighborhood, and the ride is so smooth it puts the baby right to sleep. And it's a selling feature of their suspension systems. Okay, so we want to reduce those forces, not only just for the passenger, but also for the car. Okay, because if all those forces are traveling through the chassis of the vehicle, it could potentially wear out or damage other parts as well, or significantly shorten their lifespan. Okay. So that's what the suspension system does, or at least that's what we're designing it to do. So how do we do that? Is there a magic pill? Does every vehicle have the same suspension system? Absolutely not. Okay, it depends on what the manufacturer wants. It depends on the application of the vehicle. Hey, I have a pickup truck that's going to have a different suspension system than something maybe like a Toyota Prius. Okay, smaller, lighter car that's trying to get better gas mileage. Okay. Hey, am I hauling 10,000 pounds, or am I just going on like a little short trip to the ice cream shop? Okay. Now, the most common type of suspension designs that you are going to encounter on most vehicles Okay, here are their names. Short long arm, torsion bar, or the McPherson strut. Okay, short long arm, torsion bar, McPherson strut. Okay, those are your three most common designs. Now, are there variations of these three designs? Yes, 100%. Okay, but if you can understand these three designs, what components they have, how they're arranged, you've got like 96.2% of what you're going to probably encounter. Okay? And even then, when you find a modified version of one of these three, you still have enough base information to where you could probably be like, oh, well, this is a McPherson strut design. Even though it's not the same type of McPherson strut design as you would find on vehicle X or vehicle Y, right? So again, we're just trying to break this down into like easy chewable steps to where you kind of get a again, basic fundamental idea. When you go into art class, they're not teaching you about the 3 billion different shades of red that you could use. They're just teaching you this is red, this is blue, this is yellow. Yeah.
Are there like other designs of suspension that aren't like modified versions of those?
Of these? Probably. I can't say definitively though. This is what you're going to encounter. I'm thinking of like trying to like get like specialty things like race cars and stuff, but typically even race cars are going to use mostly this right there. They call it something a little different though, but it's a yeah.
Which one of those with like double wishbone suspension clogger?
Short long arm. Yep. Good question. We'll get into that when we get into short long arm stuff here. Okay. So we've identified what suspension systems do what they're supposed to do. We talked about the three different main types of suspension systems you're going to encounter. Okay. In addition to the types of suspension systems, one of the easiest ways to begin to identify the type of suspension system is what kind of spring is utilized in the suspension system. Okay. Okay, and there are 4 main types of springs that you're going to see. Okay, and I mean, you could attempt to try to draw this stuff. Probably one of your most common types is going to be our coil spring. When I say the word spring, this is probably what comes up or what you're thinking about in your head. It's literally a rod of metal that's twisted and turned into a coil. Okay, as I push down on this, it pushes back up like this, and it can expand and contract, right? If you slap these on the bottom of your feet, you start bouncing up and down, right? It feels like you're super lightweight.
You've done that?
I know I haven't.
Oh.
I'm just saying, like, have you ever seen old cartoons? Maybe I'm dating myself. Put Bugs Bunny on these things, he goes crazy. Now, I'm just gonna throw this out here. These springs are not the type of springs that you're normally encountering. Okay? These aren't springs that, oh, hey, I can compress and expand them and bounce on them with my feet. Okay? What are we trying to hold up?
A car.
A car.
Or a
How much
truck.
does a car weigh?
More than you?
Right? A little bit more than me. I mean, we're talking 3, 4, 5, maybe 6,000 pounds. Okay? So in this case, we're looking at hundreds, if not thousands of pounds that is compressing these springs. Okay, we're going to get into this a little bit more later on in the presentation. I'm just going to let you know, you're not going to be able to take this spring and compress it yourself. You can stand on this thing all day, the spring's going to laugh at you. Okay, because you just don't weigh enough. Because these are designed to hold up the chassis of the vehicle.
What about me?
Especially you.
You might break.
Okay. So that's a coil spring.
I'm gonna assume squatting the truck because you're towing something that heavy is not a good.
Another more common type of spring that you're going to encounter is a leaf spring. That's this one right here.
That's common on trucks.
Okay.
isn't it?
Yes, although we're starting to see some trucks actually go away from leaf springs, and that's just a design decision in terms of rideability for trucks, because a lot of people aren't using trucks anymore for their intended purposes, right? They're like, hey, I got a SUV with a bed in the back. That's basically what they're using it for. A grocery getter. Now, a leaf spring, again, we'll get more into this later on, and you don't have to write this down right now, but a leaf spring is basically layers of steel kind of bent, so that way as you are essentially pushing on this, it flexes, and because it's metal, it has a memory, and it's going to bend back and resist those forces. Okay, so there's that. We've got airbags. Like literally, like very, very rugged rubber balloons. Okay, we can inflate that with some compressed air, right? And as the forces are acting on the wheel to force it down to the ground and holding the chassis up, that bag is going to flex and move. Okay,
That's cool.
way cool. Okay,
Way too cool.
So typically not found on most vehicles, although sometimes you're going to find it on some vehicles in the rear suspension due to just aiding a coil spring or potentially being able to adjust the rideability of the vehicle. That's a very easy way to do that. Okay, and then finally we've got our torsion bar. Question? No? Okay. Torsion bar. This one hurts a lot of people's heads to kind of understand how this works. Okay, because it's not like a normal spring. Okay, basically a torsion bar is a lateral spring. It's literally a metal bar. Okay, and as that metal bar is twisting, torque, it's storing up and releasing energy. Okay, so that's why it's called a torsion bar, because it's a lateral coil. It's just basically a metal rod that's twisting.
And they look cool.
Okay, they look great. So again, utilized, probably not super common anymore, but it is a spring, even though it might not quote unquote look like a spring. It acts like one. Go back. Yeah, I can't wait. We got to move on. Okay. Again, I want to emphasize this for learning purposes. There's vocabulary that you now need to start to learn and understand what the definition is for these words. Because this is words that use to communicate information to those in the industry. Okay? So our first word that we're going to define is sprung weight. Okay? Sprung weight. That's not a made-up word. I mean, all words are made up, but what does sprung weight mean? Quite literally in the blue.
Weight of the vehicle that holds the suspension equal to overall weight minus the unsprung weight.
Okay? All the vehicle's weight supported by the suspension. So on the study guide, there's going to be a thing. It's going to say unsprung weight, sprung weight. What's the definition of sprung weight?
Vehicle's weight.
If you have this written in your notebook, you have the answer. You could literally just type it in. Oh, here it is in my notes. Boom, 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 boom.
Doesn't it say like not to use your notes on this thing?
Yes. Now you can put this in your own words. And you need to have this memorized. Let me put it that way. What is sprung weight? It is the vehicle's weight which is supported by the suspension. Okay? That's all it is. It's nothing fancier than that. But we are distinguishing what is supported by the suspension and what is not supported by the suspension. We're making a distinction between the two. You're going to need to identify parts on the vehicle that is supported by the suspension.
Chassis.
Okay? And you are going to need to identify parts of the vehicle that is not supported by the suspension.
Wheels.
Okay? In order to be able to know what parts fit into each category, you need to know the definition of what it is. Right? Am I making myself clear on that? Okay. So, one thing to keep in mind that vehicle manufacturers, if I have more sprung weight, the better the ride quality is going to be on my vehicle. The heavier my chassis is, the better that's going to be able to respond as I'm driving down the road. It's going to be more comfortable. It's going to be able to pick up all sorts of bumps and stuff along those lines. It's going to have a better ride quality. Okay? The suspension is going to be able to act better when compared to lighter vehicles. Okay. All right. So, sprung weight is everything supported by the suspension. Unsprung weight is the opposite of that. It's all the weight not supported by the springs.
Dude, Mr. Getzky, you tried the purple nerf on me.
Mason, can you shoot it?
Well, I'm glad we're back to middle school.
We were just doing so good.
No, I'll be frank with you, right? There's more sprung weight than there is unsprung weight on the vehicle. That's by design. But think about this. Everything that is attached to the car's chassis, everything attached to the car's chassis is sprung weight.
So like the frame?
That's the chassis, yep.
So what's not supposed
Engine, transmission, steering wheel, seats, windows, passengers, right? All of that's attached to the chassis of the vehicle. That is sprung weight. It is supported by the suspension.
So what would be unsprung weight?
What's unsprung weight? Basically, the opposite of that. Everything that's not attached to the chassis.
So
It's not.
Okay? So tires, that's unsprung weight. That's not being supported by the suspension system. Okay? Now, is it attached to the suspension system? Yes. But the suspension system's not holding up the wheel. Right? Okay? Your brake system, that is attached to the steering knuckle, which we'll get into more of those components, right? Your suspension systems in general is going to be unsprung weight. Okay? Now, we mentioned previously that sprung weight, the more sprung weight you have, the better the ride quality you have. The opposite of that is also true. The lighter the unsprung weight is, the better the ride quality is. Okay? If I have a light tire and a light braking system, my suspension system is able to actually react and move much faster. Okay? It's a physics thing. An object in motion wants to stay in motion, an object at rest wants to stay at rest. If I have a heavy chassis, it's going to take a lot of energy to be able to move that out of the way. So the heavier it is, the more it wants to stay in place. The lighter my suspension is, the quicker I can actually move my wheels and stuff, and that way I can actually maintain on rough roads at a higher rate, which means a smoother ride. Does that make sense of how I'm describing that?
Yeah.
Is there anything not clear about that? I hate asking the question, does that make sense? Because everyone can just be like, yeah, without necessarily understanding if that makes sense or not. I'm trying to do my best to describe this. Remind me, seriously remind me, not today, but probably later on when we get further down the line with suspension systems, I want to show you guys a technology that was developed in the 80s by Bosch, which is stupid awesome. Okay, the problem is it was left in the 80s and it was never actually further developed and implemented in suspension systems. But basically, it allows the vehicle to drive across the craziest terrain, and the vehicle just stays put, and everything's moving. It's
Did I ask you, what's it called?
what?
What do you want us to remind you to say?
To remind me to show you the video on Bosch active suspension.
Right.
Okay.
Why is that?
Yeah. It's wild. When you look at it, you're like, that doesn't even make sense. It hurts your head.
Is it like that thing?
Not entirely, but it shows you the kind of cool factor between sprung and unsprung weight. All
Like
right,
the Fox suspension on the.
not quite. Okay, another vocab word, another term that you need to know what it's called and what it is. Spring rate. Okay, how do we define what spring rate is?
The amount of load necessary
It
to.
is the
deflect
amount of load necessary to deflect the spring 1 inch. That is a very specific measurement. Okay? It is the amount of load necessary to deflect the spring 1 inch. Which isn't much, right?
It's like that much.
Yeah. How much load do I need to add to my suspension spring in order to basically make it 1 inch shorter? Different springs have different spring rates. One spring, it might take 400 pounds to compress it 1 inch. Another spring might take 250 pounds. Okay? There are also variable springs, which we're not going to get into, but depending on how much is loading or actively loading, it can change. It might take 120 pounds to squish it the first inch, but then an extra 300 pounds to squish it the next inch. Okay? Most springs just have a standard spring rate that's consistent throughout the range. Yes?
So, if we're looking at that picture, the both.
Which picture?
Nope. Nope. Yep.
Yeah.
The 200 pounds in springs, B and C.
Okay.
Why are their spring forces different?
Only 120 pounds. That's it.
It's an example.
Oh, that's what's that.
Okay. Remember, for every action, there's an equal and opposite reaction, right? So if I'm compressing at 400 pounds, that means the spring is pushing back 400 pounds.
How much is like a spring usually? With 120 is like.
No, yeah, you're looking at hundreds of pounds. Like 500 pounds. It's like I said, if you took the spring out and tried to compress it, it would take 400 pounds, let's say, to push it in 1 inch.
Jeez.
Right? That's why any human being could stand on top of one of these springs and it's not going to deflect much.
What if
Right.
you made like a human? Wait, you never answered my question.
What's the question?
Why does D go less than C? They're the same length and they're both pushing in the same power.
Maybe like the spring's like thicker or some shit.
Right. There's variations or
Or stuff.
variable differences between the two in terms of how it was made, how many coils per inch it was wrapped, the thickness or diameter of the rod that was used. I mean, we could go down a rabbit hole with this, and we can get super nerdy, but
But it's just like different brands, different types of.
yeah, it's just how it was manufactured.
Alright.
But then they would take it into a tool like this, and they can measure it and go, okay, we designed this to have a spring rate of 400 pounds, right? Then we come close with our mathematical calculations. Okay, let's go ahead and exit out this door 41.
Yo, I'm bringing my mom, dude.
I'm going to temporarily pause this.
You had my weed?